So welcome back to the Java OCP 21 series. I am Arup Basu from ClusterMicro Technologies. So in the previous videos, we covered local date, local time, local date time, period, duration, and instant. All of those classes have one thing in very common. So they have no time zone. So they represent dates and times without any awareness of where in the world you are. So in this video, we are adding the final piece, zone date time and the daylight saving time. Okay, this is the most complex topic in the entire date time section of the OCP exam and one that produces the most surprising results if you do not understand what is happening underneath. Okay, so let me tell you upfront what the exam tests here. Okay, it does not test whether you know DST exists. It tests two very specific behaviors. What happens when you try to create a zone date time at a time that does not exist because the clocks have moved forward? And second, what happens when you try to create a zone date time at a time that exists twice because the clocks have been moved back? So both of these situations have a specific defined Java behavior that you need to know exactly. So let us start with zone date time creation and then move to DST. Okay. All the date time classes we have seen so far, local date, local time, local date time, are described as local because they have no time zone. They represent a date or time without specifying where in the world that date or time applies. Zone date time is different. It is the full package, a date, a time, a UTC offset, and a time zone name all in one object. Okay, so when you have a zone date time, you know not just when something happens but where in the world that time applies. Okay, so this matters enormously for distributed systems, global applications, and anything where users in different time zones need to coordinate. And it matters for the OCP exam also because time zone behavior is specifically listed in the syllabus objective. Okay, so next we come to the code. We have ZoneId zone equal to ZoneId.of Europe/London. So ZoneId represents a time zone. You create one using ZoneId.of and passing the IANA time zone name. So international, which is the international standard for time zone identifier. Okay, identifiers. The format is always region/city. So we have Europe/London is the UK time zone. Okay, Greenwich Mean Time in winter and British Summer Time in summer. Other common ones on the exam are America/New York, America/Los Angeles, Asia/Kolkata, Asia/Tokyo, then Europe/Paris. So these are case sensitive and must match exactly. Okay, and then we have zone date time ZDT equal to ZonedDateTime.now zone. Okay, so this captures the current moment in time and attaches specified time zone to it. The result shows the current date and time as it appears in the Europe/London zone, including whatever offset is currently in effect, which changes depending on whether DST is active or not. Then the third line says zone date time fixed equal to ZonedDateTime.of 2025, 3, then 30, 10, 000 zone. So this creates a specific zone date time using the off factory static method. Okay, the arguments are year, month, day, hour, minute, second, nanosecond, and then the zone ID. So 8 arguments in total. The date here is 30th March 2025 in the Europe/London zone, 10 AM. Okay, so this is a deliberate choice. 30th March 2025 is the date the UK clocks spring forward. So we'll come back to this in a moment. Okay, so when printed, a zone date time shows the full information, 2025 03 30, then T 10 10:10, then +01, then :00, then Europe/London. The +01:00 is the UTC offset. Okay, in this case British Summer Time, 1 hour ahead of UTC. Then we have DST Spring Forward. We have 3 more lines of code. We have ZoneId UK equal to ZoneId.of Europe/London, then zone date time gap equal to ZonedDateTime.of 2025, 3, 30, 2, 30, 00 UK, and then we have system.println gap. Okay, so here we now reach the heart of the slide. Okay, the spring forward DST transition. So let me first explain what happens to clocks in the UK on 30th March 2025. At exactly 05:59 AM, the clock spring forward. Next second is not 02:00:00. Okay, the next second is 03:00:00. Okay, the clock jumps 1 hour forward. This means the entire hour from 02 AM to 02:59 am simply does not exist on that day. It is a gap in time. The clocks keep it entirely. This is why it is called spring forward. In spring, clocks move forward and we lose 1 hour. So now the exam question is, what happens if you try to create a zone date time at a time that does not exist? Okay, so here we have a line. This says that zone date time gap equal to ZonedDateTime.of 2025 3:30 2:30, 00 UK. Okay, so we are trying to create a zone date time at 0 to 30 am on 30th March 2025 in the UK. But 0 to 30 am does not exist on that day. The clocks keep from 01.59 directly to 0300. Okay, there is no 02.30. So most people's first instinct that Java will throw an exception. Okay, it refuses to create a time that does not exist. But Java does not throw an exception. This is a key fact you must remember. Instead, Java silently adjusts the time forward by 1 hour. 0 to 30 does not exist. So Java moves it forward to 03:30, okay, the equivalent time after the clock has jumped. So if you do system.out.println gap, so it will print 2025 03:30 to 3:30 plus 01, then 00 Europe/London. The resulting zone date time shows 3:30, not 2:30. Okay, so Java adjusted it automatically without any exception, without any warning. The code will compile and it will run. Okay, so it produces 03:30. The offset of plus 0100 tells you that at this time UK is 1 hour ahead of UTC. Okay, the British Summer Time is now in effect. So this is the spring forward rule in Java. If you create a zone date time in a gap, a time that does not exist because of spring forward, Java does not throw it. It adjusts the time forward to the equivalent time after the transition. Okay, the exam will show you exactly this pattern and ask, what does gap contain? The answer is 3:30, not 2:30, and not an exception. Then we go to slide 3, DST Fall Back and adding time across DST boundary. Okay, so spring forward was about a gap, that time that does not exist. Okay, fallback is the opposite problem, a time that exists twice. So in autumn, clocks go back 1 hour. At 2 am, the clock is turned back to 01 am. Okay, so this means the hour from 0100 to 01:59 am happens twice. The first time at the summer offset UTC plus 1, and the second time at the winter offset UTC plus 0. So if you look at wall clock at 01:30 am, you cannot tell from the clock alone whether you are in the first occurrence or in the second occurrence. Both look identical on a 12-hour clock face. So this is the ambiguous time problem, and again Java has a specific defined behavior for it. Okay, so fallback. So if we see the code here, we have zone date time ambiguous equal to zone date time of 2025 10 26 1 30 00 UK, and then we have system.out.println ambiguous.getOffset. Okay, so on 26th October 2025 the UK clocks fall back. So at 2 am they go back to 01 am. So hour from 0100 to 01:59 repeats. Okay, so the first line, if we see zone date time ambiguous equal to ZonedDateTime.of, etc. So we are creating a zone date time at 01:30 am on 26th October 2025 in the UK. But which 01:30? The one that occurs before the clock goes back at UTC plus 1, British Summer Time, or the one that occurs after the clock goes back at UTC plus 0, Greenwich Mean Time. Okay, so again Java does not throw an exception. It picks one, and the rule is very specific. Java uses the earlier offset, the first occurrence. The first occurrence of 01:30 am on that day is while we are still in British Summer Time at UTC plus 1. The second occurrence will be after the clock has gone back at UTC plus 0. Java picks the first one, UTC plus 1. Okay, and then we do system.out.println ambiguous.getOffset. So it will print plus 01:00. The The offset is +010:00, confirming that Java chose the first occurrence, the one in British summertime before the clock went back. So the fallback rule in Java, if you create a zone date time at an ambiguous time, a time that exists twice because of the fallback, Java does not throw. It uses the earlier offset, which is the first occurrence of that time. Spring forward gap time, Java adjusts forward, no exception. And fallback ambiguous time, Java uses the earlier offset, no exception. Okay, so these two rules together cover every DST question on the OCP exam. Okay. Then adding time across DST boundary, if you see zone date time before equal to ZonedDateTime.of 2025-330-0000 UK, and then zone date time after before dot plus hours force, and also you have system.out.println after dot get. Right, so here what happens is that the first line, zone date time before, we create a zone date time at midnight, okay, 00 AM on 30th March 2025 in the UK. This is before the spring forward transition, which happens at 01:59 AM. At midnight, the UK is still in Greenwich Mean Time, UTC +0. Then we have zone date time after equal to before dot plus hours 4. We add 4 hours to midnight, simple addition. So midnight plus 4 hours should give us 04 AM, right? So think about what happens to the clocks during those 4 hours. We start at 00 AM. 1 hour passes, it is 01:00 AM. 2 hours pass, it is 01:59 AM. At 01:59, the clock springs forward to 03:00. So the third hour of elapsed clock time takes us from 01:59 to 03:00 and then onwards. So by the time 4 real hours have elapsed, the wall clock shows 05 AM and not 04 AM. Okay. Zone date time tracks real world wall clock time. It is zone hour. So when you add hours to a zone date time, so it follows the actual clock in that time zone, including any jumps caused by DST transitions. Okay. So next we have system.out.println after.getHour. So it will print 5, not 4, 5, because the clock jump forward by 1 hour during the 4 hours we were counting. Okay, this is the crucial insight. Adding hours to a zone date time gives you wall clock time, what the clock in that time zone actually shows after that much time has passed, including the DST adjustments. Okay, if DST causes a 1 hour jump during your addition, the wall clock results shift by 1 hour. Okay, if instead you added hours to an instant, you would get pure elapsed time. 4 hours is always exactly 4 hours, okay, regardless of DST. The instant has no concept of time zones or clock adjustments. This is one of the practical reasons why instant exists, okay, for measuring pure elapsed time without DST implications. So you have to remember 4 rules here. First is zone date time is created using ZonedDateTime.of with a zone ID. The zone ID is specified using IANA format, Europe/London, America/New York, Asia/Kolkata. So case sensitive. And second, spring forward, the gap rule. When you create a zone date time at a time that does not exist because the clocks have moved forward, Java does not throw an exception. It adjusts the time forward to the equivalent time after the transition. Okay, 0 to 30 in a spring forward gap becomes 03:30, no exception. And then fall back, right? The ambiguous time rule. When you create a zone date time at a time that exists twice because the clocks have moved back, Java does not throw an exception. It uses the earlier offset. The first occurrence of the time. GetOffset returns the summertime offset, UTC +1. Okay, and then adding hours to a zone date time gives you wall clock time. So if DST causes a clock jump during the addition, the result reflects that jump. Midnight plus 4 hours on a spring forward day gives you 5 and not 4. Okay, because the wall clock jumped forward by 1 hour during that 4 hour period. So you have to remember these 4 rules covering every DST question on the OCP exam. So thanks for your time. See you in the next video. If you got value from this video, please like and subscribe. it genuinely helps this series reach other OCP candidates who need it. Okay, so if you want to practice OCA questions right now, you can go to javalearn.clustermicro.com. Over 1600 questions are there, and they are timed exams, detailed explanations, and free trial available. So OCP 21 practice questions are also coming soon. You can email ab.clustermicro@gmail.com if you want early access notification. So I'll see you in the next video. Thanks for your time.